Good morning, students. Today we are solving most recent specimen paper which has been provided in 2022. Paper 5, question 1 as usual. This is the question. Read the question properly. Here two circular coils are given, coil P and coil Q. Then alternating current is given to coil P, so it will be making a varying magnetic field around it, from theory. And the second coil near to it will, there will be a change in magnetic field or magnetic flux through coil Q and EMF will be induced. This physics is like a transformer. Look, induced EMF E is I Z e to the power minus kx. What is I? I is the current in coil P. And what is E? EMF induced across coil Q, right? And X is the distance, center to center distance from coil Q. This is the equation. Now, which one is a variable? Where current I, P, Q, and Z are constant. Okay. So you cannot change the current during the experiment. It's a control variable. And E and X are variable. Look, if X is increased, then definitely less EMF will be induced. Clear? Okay. Draw a diagram showing arrangement of the equipment. Okay. Explain how this was. This question contains 15 points, 15 marks. And these 15 points, okay, totally settled down already. First one is, look, you cannot write in this sequence, right? So, as usual, you can write a paragraph. Teacher will find related points. Another way is you may write the way Merck scheme represent, right? This is the Merck scheme. Anyway, if you answer in that way, at first write defining problems, method of data collection, defining problems, 2 marks here. Then method of data collection, there are 4 marks here. Then analysis, 2 marks only. So in total 9 marks here. Then remaining 6 point, it is in additional details. Look, in first part, just declare the variables, right? Defining problems and write the constant. Write all constant. That means all quantities involved here, right? Other than variables, write them constant. If it is demarked, teacher will decide, right? Demarked means what? Additional details, right? But you can write all constant term, what you think, right? Should be kept constant in this defining problem part, right? And again, some additional details might be added during the what description of method of data collection, right? If you think that okay, some points still remaining, you should write it separately, then add it to the additional details. Clear? So according to my okay suggestion what to do. At first, declare variables. Okay. Then add a workable, okay, add a suitable diagram. That means, look, this coil must be what supported somewhere. And there must be a way to measure X. There must be a way to measure induced EMF. So what thing can measure the induced EMF? You can use a CRO, or in this case, okay, we need to use CRO. You can use a AC voltmeter. If you add a AC voltmeter, it will record RMS voltage. So no problem. Okay, so you'll get EMF in the form RMS. Doesn't matter. Now you can look. The factor is I is not a variable. Variable is X, separation between coils. So you have to keep I constant. And you know, even if you keep the voltage constant here, current might be changed because coil is heated up, so its resistance changes. So that's why, okay, current needs to be adjusted during the experiment, right? It might be changed. Therefore, you need a variable resistor to control the current, right? If it is changed, it should be kept constant, regulating the variable resistor, right? Okay. Now, how can you measure X? And another thing, this coil, okay, cannot be kept vertical in this way easily. So you should clamp it. You can place these two coils on a support also, or you can hang them by what? By clamp and stand. Okay, by clamp and stand. This is the this is stand one, and this is stand two. This is another stand. Okay, meter rule, you can place it at the center exactly, or you can place it at the base also. Clear? This is a roughest case. Uh, A. And another thing, this coil surface must be vertical, so you can attach a what? Set square. Okay, place a set square here to confirm that both of these coil surface is vertical with the ruler. Okay, and ruler must be kept horizontal. It can be ensured using spirit level, right? Look at this procedure. These are procedure overall. Measurement taken. Yeah. Now, this is a diagram which can be used. Look at this. You don't need to draw what a perfect diagram, right? Just you are sharing your idea. What thing do you want to do, right? So in that case, this is coil P. Look at the picture. Coil P and coil Q, both of them supported by two stand. Meter rule is placed here. You see, this is the meter rule. Then variable resistor ammeter is there. High frequency signal generator. Look, you can add AC supply, but better you write signal generator, because in this experiment, if you want to see higher voltage here, then you have to use high frequency signal generator. You know, regular AC supply, it is fixed at 50 hertz. So if you want bigger frequency, higher frequency, then signal generator should be used. Clear? So that's why signal generator added here. Now this is the set. Lamp is here. Okay. You need to show all apparatus. For example, you need to use spirit level. Spirit level usually it is placed over the ruler here. It is a bubble at the middle. When this bubble remain at the center, then it is ensured that it is horizontal. Okay, if it is at one side, adjust the height. So this is the setup. Now I told you at first, write defining problems. Okay, what variables here? Main variables are x and e. Look, x is the independent variable because you can change x by yourself directly, right? You don't know what will be the EMF that is settled down later on. So the thing that okay, you can change independently is the independent variable, right? You have the freedom to change x. E induced EMF will be settled down later on. Clear? Okay, so x is the independent variable, E is the dependent variable. Keep I constant, right? And other things which should be kept constant mentioned in this part also, don't worry, right? So what thing? Number of turns. If you use greater number of turns in coil P, it will create greater magnetic field. So which results to greater EMF in coil Q, right? And again, if you use more turns in coil Q, greater EMF will be there. Why greater EMF is very important? Because when you are measuring EMF, if its value becomes bigger, it can be measured with higher accuracy, okay, with less percentage uncertainty. So always we want to make the dependent variable higher, right? But you cannot change the turn, okay, during the experiment. You should use greater number of turns, but you cannot change it during the experiment. So defining problem. What did I write here? X is the independent variable, E is the dependent variable. RMS current I of the coil P cannot be changed. This is the main constant actually. This might be added to the additional detail, but okay, you don't know the merge scheme during the time of answering, right? So that's why write the all constant that should be okay kept fixed during the experiment. Look, all variables mentioned here. So number of turns of each coil cannot be changed also is a point here. Now come to the method of data collection. Look, in this part actually your focus will be how to measure dependent variable and independent variable. Clear? How to measure dependent variable and independent variable and how to change independent variable, right? Okay. So for each measurement of x, at first distance d between two inner surfaces of coils is measured using meter rule. S-square is used to reduce parallax error and also to ensure that these coils are vertical. Split level is used to ensure that meter rule is horizontal. Okay, this might be in more scheme, this might be in additional details, but write it in your own way, right? Then if you think that, okay, some problems, some other things should be mentioned, mention it in the later part. But in this part, you have to, okay, keep your focus only to measure dependent and independent variable and how to change them. So for accurate measurement, x at first distance between two inner surfaces. What is this? Look, x is actually center to center distance. So you can do this in two ways. You can add a cross wire here to get the center, then center to center distance can be measured using meter rule. But better you place the meter rule at the edge, then measure the distance from face to face. Face to face means this distance, right? To front. What? Then get the thickness of each coil. Half of this thickness will be added to each side, right? So that's why it is written here. For accurate measurement of first distance d between two inner surface of the coil is measured using meter rule. Set square is used to reduce parallax and also ensure that coils are vertical. Okay, look at this. Set square is confirming this two coils whether they are vertical or not. So hope you understood. Okay, now come to the next part. Okay, with two coils W1 and W2 are measured using meter rule. Width, right? Then X is distance between two inner surfaces plus half of the width of first coil, half of the width of the second coil, right? Separation of coil is changed and corresponding V are recorded. How can you change X if you increase the separation between coils? Method of analysis. Look, in this part, anyhow, you have to, okay, plot a straight line. You have to change the quantity in x-axis and y-axis so that it becomes a straight line, right? It may or may not go through those, it doesn't matter, but you need a straight line in this part. So if you take ln at two sides, ln E is equals to ln Iz minus kx, graph of ln E, again ln is plotted. Look, it is y equals to mx graph. It is y equals to mx graph. Look, ln E is y variable, whole thing is C plus mx. It's okay, it's a straight line, but not passing through the origin. Gradient is minus k, C is all this. So, okay, what is written here? Graph of what? Ln E against x is plotted. Graph of ln E against x is plotted. It is y equals to c plus m is graph. A straight line would be there where gradient is minus k. Look, in the main question there were a demand, right? They asked you to determine k and z. Okay, one thing is not mentioned here, unfortunately, so write it. Current I is recorded. Current I is recorded. Okay. Current is constant, but there should be single measurement for it. So if you know the current, then easily you can determine Z in this way. 1 to 6 right? Now I'm adding additional details. If you think that some other thing should be mentioned as a precautions, safety precautions and regular, okay. precautions, then you can add it here. Look, it could be like this. At first, mention safety precaution and mention it. This is safety. You're writing this for safety. Mention it clearly. So coil, definitely coil will be hot. You're giving higher current hit. So you cannot touch it. Or if you want to touch that, if you need to touch that while you are changing the uh, coils, in that case, where what heat sensitive, sorry, heat proof gloves, right? Okay. Larger current ensures more current, more EMF, more number of turns also ensures more EMF. It is added here in this part. Large current and also more number of turns should be used so that strong magnetic field is produced and higher value of EMF will be induced. High frequency AC can also generate higher EMF, so you can use high frequency AC. Current is kept constant using variable resistors. X should be measured from, this is a precaution actually. We want to repeat same measurement for greater accuracy. So X should be measured from different parts of the coil and average EMF should be, uh, it is not EMF, it's a mistake. And average X should be determined. Clear? When X is measured, ruler should be horizontal. It is mentioned already. So you don't need it. Remove it. It is already mentioned. So these are the points. Clear? Very simple. Declare variables. Mention constant quantities. Draw a diagram to make it more realistic. In that part, you should focus on how to measure independent and dependent variable, and also constant quantities should be measured once, right? Okay. So then in this part, you have to mention how independent dependent variable are measured, how you can change them. Then in the data, in the method part, just keep focus how variable can be changed, right, along x and y axis so that you can plot a straight line. Try to make it y equals to mx graph, right? Okay, that's why we took ln here instead of e. If you see other values, right, then you can use log in that case. Okay, this would be a straight line. Look at this. Y-intercept is this, then IZ is e to the power this. This is math, right? Okay. Oh, sorry, we were in additional details. So some additional details already added. Still here 5 or 6 points. Okay, added. So this is the way how can you solve question 1 of paper pi, right? Okay, I think this video will be helpful to you. Bye bye.